the grass, silently watching the rain clouds move by fast.
Okay, we're going to finish off section 3.2, which is on the law of sines today. And bad news, this is going to be a long video and it's going to be a difficult video. This is quite possibly, as I said in the last video, this is quite possibly the most difficult lesson of the whole course. It's about the sine law again, and it's about the ambiguous case. So what does ambiguous mean, first of all? Ambiguous means unclear or open to more than one interpretation. So if I said to you, hey, let's meet tomorrow at 7 o'clock, see ya, and I just left you standing there, that'd be ambiguous. You'd be like, well, 7 o'clock, is that in the morning or is that in the evening? It's not clear. There's more than one way you could interpret it. So that's what ambiguous is. So basically, when we are talking about the ambiguous case, what we're talking about is, and we talked about this last time, the dreaded AS situation. Remember, that's a triangle where you have one angle and then two sides that you know, and you have to figure out the rest of the sides and the angles. So the reason you can also call this SSA, but the reason I call it this is because then we remember that this is the pane in the ASS. Okay, remember it's different than SAS. SAS is when you know the angle between the sides, but this is the case you don't know the angle between the sides, you know a different angle. Okay, if you're actually given a drawing, so if you're actually, there's a question, and here's a triangle, and they give you one angle, let's say this is 40 degrees, and they give you two sides, well, let's say this one's 12 and this one's 10. And they say figure out the rest of the information, the other angles and the other sides. That's not ambiguous. The reason it's not ambiguous is because they give you a drawing. So I'm going to put that in words here. It's not ambiguous if the drawing is provided for you. What is ambiguous is when they just give you the information without a drawing. So for example, and this is going to be our first example, if they told us that angle A is equal to 30 degrees, side A is equal to 4 centimeters and side B is equal to 10 centimeters. If they just gave you this information and said find the other sides and angles, that'd be ambiguous, and you're going to see why in a minute. Okay, so there are 5 different possibilities, and really there's 6. When I think about it now, there's actually 6 different possibilities we have to go through. So here we go. If I get a question like this, when I get a question like this and I see it's a pain in the ass question, the way I start is by drawing the angle, and I always draw it like this. You don't have to, but in my experience this is the best way to do it, is to put the angle down in this corner here, like in the bottom left. And so this is angle A, and it's 30 degrees. The next thing I do is I name this side, and there's 2 sides I know. Could this be side A here? No, it couldn't, because side A has to be across from angle A. It has to be somewhere over here. So this would be side B. So I'll label this as 10 centimeters. Now, here's the thing. We don't know, because there's no drawing, we don't know how that third side, how it's drawn. Is it drawn down like this? Is it drawn over here? Is it drawn down? We don't know. So, and in fact, I know this is ridiculous, but sometimes it might not be possible to make a single triangle at all, and that's actually going to be the case here. You can see it says no triangles possible. So the question I have for you is, if you wanted to try to make a triangle, what's the shortest line you could draw to connect this line here down to anywhere on this line? Remember, this bottom side here, we don't know how long this is, so I don't know. I can draw it really, really long because I don't know, and I just have to reach that red side somewhere. So where would be the shortest line? The shortest line would be if I went straight down, not at an angle. I went straight down, and in doing so, what kind of angle do I make here? I make a right angle. So I now have a right angle triangle. So what I want to do is I want to know how big is this distance, because whatever distance that is, that's the minimum I need to make at least one triangle. So I have to figure out that distance. In the book they always call that distance h. I don't know if it's for height or what, but I'll call it h just like them. So you can go back to what we did last year and the very start of this chapter this year. Since this is a right angle, you're allowed to use sine or cosine or tan. So let's look from the 30 degrees. This side is opposite, and this side is the hypotenuse. Opposite and hypotenuse, which one's that? It's sine. So sine 30 equals the opposite, which is h, over the hypotenuse, which is 10. And remember the way we solve them, or I like to solve them, is you put this one over 1 and cross multiply. So what you're going to get is h is equal to, and you're going to multiply these two together, it's equal to 10 times sine 30, and then divide it by the one that's left over, which is 1, which makes no difference. And if you do that, you're going to get the answer 5. So the minimum amount you need in order to make a triangle is you need to have 5 to get from here to here. This is side A, right? Across from the A. How much do we have that side A is? We have that side A is 4. So is that enough? No, it's not enough. If we were to draw that 4, it would only come down to, I don't know, somewhere around there, and that'd be it. You can't even complete the triangle. So, because this 4 here is less than 5, the minimum amount, this is the minimum to make a triangle. And since we don't even have that, therefore, no triangle. It's not even big enough to make a single triangle. Okay, I hope that makes sense. Possibility 2, only one triangle is possible. So the example we'll give for this one is, we're going to use 30 degrees for all these. The reason is because 30 degrees is really easy. When you do sine 30, it's 1/2, so it just makes my life a little bit easier when we're doing the math. But it doesn't have to be 30. Angle A equals 30 degrees. Side A equals 7 centimeters and side B equals 14 centimeters. So again, the way I like to start is to always put the angle we know down here. The angle we know is 30 degrees, so angle A is 30, and then I like to name this side. And that can't be side A because side A has to be across from it, so it's side B, which is 14. And then what we want to do is we want to figure out what's the smallest possible side length we need for A in order to make a triangle. Is 7 enough to make a triangle? So the smallest possible amount will be, again, always will be this straight down line. That's a terrible dotted line. It makes a right angle, and we want to know how much that is. So what we do is sine 30, it's always going to be this way. Sine whatever angle, won't always be 30, but sine 30 equals h over 14, put it over 1, cross multiply, h equals 14 times sine 30 divided by 1, and if you do that you get 7. So this again, this is the minimum we need to make at least one triangle. How much do we have? We have a side length of 7. So we needed 7 and we have 7. Therefore, how many triangles do we have? One triangle. What's more, what type of triangle is it? It's a right triangle. The way it actually looks is exactly like the way we've drawn it here. So that is the triangle. You would not need this bit. That's the triangle. And then what you could do, and of course we now know how much h is. H is 7. And then you could find out everything else. And to find out everything else, you could use the sine law if you wanted to, but because it's a right triangle, you could also just use the sine ratio and the cosine ratio and the tan ratio, and you could use the Pythagorean theorem. All that stuff we use with right triangles you could use. This is the only case, possibility 2 is the only time you're going to be able to use the Pythagorean theorem and the sine ratio and the cosine ratio, etc. Okay, that's the next one. Possibility 3, only one triangle is possible again, but this time it's not a right triangle, it's an oblique triangle. So let's take a look at that one. So that would be something like angle A is 30, doesn't have to be 30, I remember just doing this to make my life easier. A is 20 centimeters and B is 14 centimeters. So hopefully you're getting the idea. I draw it like this. I put the angle we know down here, which is 30 degrees. This side can't be A, it has to be B, which is 14 centimeters. And then I want to find this distance right here, which is a right triangle. So I would have to do sine 30 equals h over 14. I believe that's exactly the same thing we did up here. I did that on purpose. So we know the answer is going to be 7 again. Okay, so over 1, and then h equals 7. So this is the minimum we need is 7. And how much do we have? We have 20. Whoa, that's a lot more than 7, isn't it? 20 is more than 7. So you're going to be able to get one triangle. So just think about how that would look. We have a long side. This 20 here is a lot bigger than 7. So where's that side A, the 20? Where's it going to go? Is it going to go like down here? No. That's going to be very little more than 7. That might be like 8 or something. If it's going to be 20, it's going to have to come somewhere out like this. Okay, I'm just approximating. But our triangle would look something like that. That would be our 20 out here, and then from there we could go and solve the triangle. Notice, see, even though we had to do this step with the h, it's actually not part of the triangle. We just did that to see if we can make at least one triangle. And in this case we can. We can make one triangle, and it's going to have a long side coming out this way. So because the 20 is more than the 7, we can make one triangle. Okay, possibility 4. At long last, we've reached the ambiguous case. This is the rotten one. So this is where two triangles are possible. For example, if we had something like angle A is, you guessed it, 30 degrees, and side A is 10, and B is 14 again. So the first thing you would do is you'd say, you wouldn't know, like if you just had this information, you wouldn't know how many triangles are possible. So you'd have to set it up. You'd say angle A is equal to 30. This can't be A, so it has to be B, which is 14. And you want to know what's the minimum amount I need in order to make at least one triangle. So you draw this, call it H, and you would do the same thing. Sine 30 equals h over 14, and if you do that, it's just like the ones we did in the previous side. It's h equals 7. So we need 7. This is our minimum we need in order to make at least one triangle. And you take a look at what we have for side A, and you can see that side A is 10. You need 7, you've got 10. So can you make one triangle? Yes, you can make one triangle. You have more than enough to make one. So what most people realize and most people think of is that you could make one triangle that looks something like that. Remember, I'm allowed to extend this one because I don't know how long it is. So this would be your 10 right there, and a lot of people are satisfied with that, solve the triangle and move on. But it's not the only way you could put this side length of 10. Do you see another way you could have put that side length of 10 that would have also made a triangle? If you spun this side downward, like along this way, it would go down to like here, and then down to here, and down to here, and I hope I'm probably not doing a very good job, but eventually you would get to the point somewhere around here where it would perfectly hit right there. Okay, so another way, let me get rid of all that. Another way you could have drawn this is by drawing that instead of putting the 10 here, you could have put the 10 there, and you'd have a very strange but valid triangle. So let me try to draw that other triangle here. What that would look like is still having a 30-degree angle, but you would have this 10 would go here instead. So I know that's hard to picture really, but this is 30, this is 14 just like it was up here, but now the 10 is here. So there's two ways that you could have a triangle that has a 30-degree angle here, has 14 here. You could either put the 10 this way or you could put the 10 that way. So there are two triangles. How do you know when you'll have two triangles? You're going to have two triangles if the amount you have, the A side, the 10, is more than the 7, so that means you're going to have at least one, but the 10, the amount you have there, is less than the 14. The A, so if you want, the other way you could say it is A is greater than H, but A is less than B. Or the other way, if you want to do it faster, H is less than A is less than B. If you have that situation where your the minimum is less than what you've got, but what you've got is less than side B, then you're going to have two triangles. Okay. Alright, that's the ambiguous case. And if you were solving this, like we're going to do down here, you'd have to solve both of these triangles. What a drag. Okay, the last type we have to look at, which is actually two different possibilities, really. There's a 5 and 6 here, is obtuse triangles. You know what an obtuse triangle is? It's a triangle that have triangles that have one angle greater than 90 degrees. So an example of that one, let's say that angle A is 120 degrees. Yay, it's not 30. Let's say that A is, well, let's come back to A in a second. Let's say that B is 16. Okay, so if we were to draw that, 120 degrees, so you better make sure you draw it bigger than 90. If you do it less than 90, you're going to get this one wrong. So this is your angle A, and it's 120 degrees, and then we're going to name this side just like we always do, and that side cannot be A, it has to be B, so this is 16. Now I want you to just think about this. if we were going to make a triangle here, what's the smallest amount you'd need to make at least one triangle? It's going to have to be, the smallest triangle you can draw is kind of a line that goes to about here. It's going to have to be just a little bit bigger than 16. It can't even be 16. 16 only gets it back to here, and that doesn't make a triangle. It has to be at least 16 point something. So, for example, if I told you that this side here was 18, that would be no problem. You could draw 18 to about there or something, and you would have your triangle. So that would be one triangle. So because 18 is greater than 16, or if you want, A is greater than B, therefore one triangle. But if I do exactly the same, angle A equals 120, and I say A is 15 and B is 16, if I was to set that up, 120 degrees, so it has to be greater than 90 here. So angle A is greater than 90, it's 120 degrees. This is our side B, which is 16, and I have 15 for my A. Well, I can't get back, I can't get far enough. My side of 15 is only going to take me back to down to about there. I can't get a triangle. So because my 15 is less than 16, or if you want, A is less than B, then there's no triangles. That's the only possibilities with obtuse. With obtuse triangles, you can have one triangle or no triangles. With acute triangles, the ones we did up here, you could have 0, 1, or 2 triangles. Wow, that's a lot of work. So now we just have one last question to do and we'll be done. Don't you feel like we're almost at the end? Surprise, we have tons of work still to do. So let's get started. It says angle P is 30 degrees, P is 24, and Q is 42. This is an angle side-side. And so this we have to check first of all to see how many triangles are possible, or maybe no triangles possible. Wouldn't that be nice? If no triangles possible, we'd just be able to say not possible and we're done. So I really wish I hadn't put 30 degrees again here, but I did. So what we do is we put angle P, the one we know, is 30 degrees, and we name this side. Is that P or Q? Has to be Q, so that's 42 here. And the first thing I have to do is figure out what's the minimum amount I need to get at least one triangle. And to do that, I do sine 30 equals h, this amount, over 42, put it over 1. H equals 42 times sine 30 divided by 1, and if you do that, you get 21. So you need at least 21 to get for this side. And how much is our side P? Our side P is 24. 24 is more than 21. Great, so we can have at least one triangle. Now, can we have two triangles? Yes, we can. How come? Because the 24 is less than the 42, right? So you could have one this way and you could have one that way. Let's draw them both. One you could have, the one that you're probably thinking of more, is this one. I haven't drawn it very well, but it doesn't really matter. This is 30 degrees, this is 42, and this is our 24. This is P. 42 was Q, so this has to be angle Q here, and angle R is there. The other one, which I'll draw over here, looks something like this. You have angle PQR again, still 30 degrees, still 42, and still 24, but this time the 24 was in here, right? One side came out this way, the other side went in that way, and they're the same length. And of course this would have to be extended to there. Okay, so now what you have to do is you have to solve both of these by using the sine law and stuff. So let's start with this one. So for the sine law, you probably don't even remember the sine law anymore, you need to find pairs. And we do have a pair here. We have this pair here. And so which angle can we find using this 42? We could find angle Q. So what I'm going to do is sine Q over side Q, which is 42, equals sine 30 over 24. And we're going to solve that by cross multiplying. So if I do that, I get sine Q equals 42 times sine 30 and then divided by 24, which leaves me with, I don't know why I did a small q there, sine Q equals 0.875. So to get Q, I have to do inverse sine or arc sine of 0.875, and if you figure that out, you will get 61 degrees. So I now know that this angle right here is 61 degrees. Remember, I have to solve everything here. I have to find all the angles, all the sides. What would be the next thing to find? That'd be pretty easy. Well, if we know angle Q and we know angle P, we can definitely get angle R. Angle R is equal to, what do they all add up to? 180. So it's equal to 180 minus the 61 minus the 30. And if you do that, you get 89 degrees. So this is 89 degrees. Little lag going on, sorry about that. Okay, the last thing we need to know, we have all three angles, we have these two sides, we need this side here. I'll call it side R, little r, because that's what it is. So again, you can use the sine law. You can use either of these pairs you want. I might as well use the one that's already highlighted, and then the other pair I have is that one there. So this time the formula I want to use is little r, because that's what I'm trying to find. Remember the thing you're trying to find, you put on top. Little r over sine 89 equals 24, that's the side length, over sine 30, which means r is equal to 24 times sine 89. Really don't like the lag, that's bothering me. Over sine 30, and if you calculate that, you will find that it's equal to 48. Okay, this side here is 48. And we're finished, but not really finished, because now we have to do the same thing again, but we have to use this triangle. Don't you hate this? Okay, so what you would do to start here is you would try to find angle Q, just like you did over here. And to do that, you would do sine Q over 42 equals sine 30 over 24. And if you take a look at what I just wrote here, do you see that it's exactly the same as what you wrote here? Exactly. So you're going to do exactly the same thing. You're going to end up down here. You're going to solve it the same way. You're going to end up with Q equals inverse sine of 0.875. And if you punch that in your calculator, I mean, I'll even show you, if you do second sine of 0.875, you're going to get 61 degrees, and that's exactly what we got there. I mean, I rounded it, but 61 degrees. So you might think, okay, well, I got 61 degrees again, but this could not possibly be 61. Why not? Because it's more than 180 degrees. So what the heck is going on here? So this is a very strange thing to teach you in foundations, because we don't really give you any explanation for this like we do in pre-calculus. But here's the thing. There's two angles that have the same sine value. Let me show you. If you took sine 30, we've talked about this all this video, sine 30 equals 0.5. There's another angle that has the same sine value, and it's sine 150. 0.5 as well. If I took sine 70, I get some complicated answer. If I took sine of 110, I would get the same. See that? So what's the relationship? 30 and 150, 70 and 110. The ones that add up to 180 are going to be exactly the same. Okay, I'm not going to get into why with that, but that's the truth. So for example, last example, if I did sine 5 degrees, I get this. That's going to have to be the same as sine of what? Remember, the two angles that add up to 180 will give you the same, so it'd be sine 175. And yep, I got exactly the same. So when you get to this point, this inverse sine of 0.875, if you were to do inverse sine, it's going to give you 61 degrees. But what you have to do is say, wait a minute, there's no way this is 61 degrees because it's obtuse. So the way you get this angle right here, this angle is equal to 180 minus 61, which is equal to 119 degrees. Maybe what I'll do is I'll go back up here, and I'm just going to write in, I'm going to name this angle B1, I'm going to name this angle B2, and I'm going to say that B2 is equal to 180 minus B1. Okay, now that we know the 119 degrees, we can finish this off pretty quick. Angle R we can get by doing 180 minus the 119 minus the 30, because they all add up to 180, right? Even in an obtuse triangle. So if you do that, you get 31 degrees. And once you know this is 31, you only need to know this side, which we'll call R again, because that's what it is. So you do R over sine 31 equals, you can use either pair you want, I'll use this one, equals 24 over sine 30. So r is equal to 24 times sine 31 all divided by sine 30. And if you divide that, you will get 25. And we're finished. Okay, I'm sorry how long this video is. I'm sorry how complicated this lesson is. I'm sure we'll go over it in class because historically people always have troubles with this. Do your best, and there you go. Worst of the whole course is over.